Casino gaming is one of the fastest growing industries in the United States. Currently, many states have some form of legalized gambling, including state lotteries and horse racing. Tribal casinos have been built on numerous Native American sites. Although gambling is controversial, it is a major industry that provides tax revenues to state and local governments. Like any industry, a casino must be confident that it will make a profit. Depending on games of chance may seem like a risky business. How do casino owners know how much profit they can expect from these games? The answer lies in mathematics, or more precisely, probability theory. This simple example illustrates how casinos can predict the amount of profit expected from a game of chance. Suppose John plays the following game with an imaginary casino. The game consists of flipping 2 coins. If both coins come up heads, John wins $1. Any other combination means that he loses $1. The expected value of this game for the casino is calculated by multiplying the payoff of each outcome by its probability. A loss is counted as a negative payoff. The probability that the casino wins $1 is 3/4 because there are 4 equally likely possibilities, 3 of which are winners for the casino. Conversely, the probability that the casino loses $1 is 1/4. Therefore, the casino's expected value is $1 times 3/4 minus $1 times 1/4, which equals 0.50 or 50 cents. So the casino would expect, on average, to win 50 cents per play in the long run. No one would play such a game because it is obviously biased in favor of the casino. Let's take this example and change the payoff to illustrate what a casino does. In our new version, the casino pays John $2.80 if he gets 2 heads, and the casino still wins $1 from John if he gets any other combination. This seems more attractive for John. He may only win occasionally, but when he wins, his profit is significantly more than he bet.
Go again?
Okay.
In this game, the probability that the casino wins $1 is 3/4, and the probability it loses $2.80 is 1/4. Thus, the casino's expected value is $1 times 3/4 minus $2.80 times 1/4. 1 times 3/4 equals 0.75, and 280 times 1/4 equals 0.70. 0.75 minus 0.70 equals 0.05. Thus, for this game, the casino's expected value is 5 cents. For this game, the casino should expect on average to win 5 cents per game over the long run. The point is that the probability of winning or losing is not the only factor. It is also important how much the bettor wins or loses. The expected value takes both probability and payoff into account. Of course, if the bettor played this game 2 or 3 times, he could easily win or lose every time. However, if the bettor played 1,000 times, he would expect to lose on average 5 cents per play. Multiply 5 cents by 1,000 plays, and the loss equals $50. This is the rationale on which casinos make their profits. As with our coin-tossing game, all casino games have an expected value associated with them. If a game has a certain expected value, and people play it hundreds of thousands of times per year, the casino can be reasonably confident in predicting what their profit will be. If they can make just 5% of the hundreds of millions of dollars wagered, they are assured of generating an excellent profit. The more money that is wagered, the greater the profit for the casino. Table games work in a similar fashion. For example, a roulette table has an expected value for the casino of about 5.3%. This means that over time, the casino can expect to keep 5.3% of the money wagered at this game. This principle also applies to slot machines. If you have 3 wheels, each with 19 spots coming up at random, how many combinations could there be? 19 multiplied by 19 multiplied by 19, or 19 cubed, equals 6,859. In such a machine, each reel may contain among its 19 symbols a single jackpot symbol. The big jackpot is won by exposing that symbol on each reel. To calculate the probability of hitting the big jackpot, you divide 1 by 6,859, equaling 0.000145. In this example, the probability that the player will win the big jackpot would be 0.0145%. You have the potential of winning a large amount of money, but at a low probability. The expected value of a slot machine for the casino is usually anywhere from 5 to 25 cents per dollar wagered, depending on the amount of money the machine pays with each jackpot. Modern slot machines are somewhat different than our example in that they utilize computers to randomly generate where the wheels stop spinning. However, the underlying mathematical principles are identical. Many types of electronic gaming machines are designed and manufactured by International Game Technology, located in Reno, Nevada. IGT distributes gaming machines worldwide and is a publicly held company traded on the New York Stock Exchange.
At IGT, we use math every day in our group. The math we do is primarily probability-based and some statistical analysis. Every day we're creating new games, new pay tables. We have to figure out the probability of different events occurring. Sometimes it's quite simple, using basic formulas and algorithms, and other times it gets extremely complex. But not a single day goes by that we don't use a higher level of math, because we're responsible for putting the whole package as the player sees it together to make the final product. We sort of drive engineering and graphics in the directions we want to come back to the core, because the core is the mathematical base. So the whole creative process is combined with the mathematical functions and abilities to create a product for us. And I credit this to my mathematical background, that understanding the big picture and how to get there is a huge advantage, especially in the design process. This goes into a lot of different areas, where just learning how to think. I mean, people ask me at my university, what did I really learn with my degree? And I sit back and think about it, and the thing I learned the most was how to think. That's what I learned going to college, and that's something, you know, I don't remember test grades, I don't remember all the formulas. That's what textbooks are for, so I can go back and reference. I learned how to look up information, how to process it, how to come to answers to questions, and other people don't know how to just solve the problem, and to me that's the fun of it. It's very rewarding.
Mathematics is often employed to predict the outcomes of given events. In this example, casinos use probability theory to determine the amount of profits they can expect from their games of chance. Mathematics in general, and probability theory specifically, are also the fundamental tools used when companies such as IGT design and produce electronic gaming machines. Determining the odds is just another example of math in action.